This screencast is going to look at how to conduct power analyses using Gpower software. A power analysis is a way of calculating the sample size required to find significant effects and have the ability to reject the null hypothesis when it is false. We can conduct two different types of power analysis. An a priori power analysis is conducted before the main study is run and often uses previous data from literature or a pilot study as a basis for calculating the number of participants required for the current study. A post hoc power analysis can be conducted when data has been collected to see whether there is enough statistical power within the data. This screencast will focus on a priori power analyses, as a priori power analysis is considered superior to post hoc power analysis. Gpower is a free software that you can download from the internet to your own computer. It allows you to run power analyses on several different statistical tests. The main ones that we are going to focus on today are independent samples t-tests, regression, repeated measures ANOVA, and a factorial ANOVA. For all power analysis, we will set the alpha error rate at 0.05 and a power level of 0.8. We also need to know the effect size. We can estimate this by using conventional criteria for small, medium and large effect size values. A better way is to use an estimate available from previous data, such as a pilot study or the available literature. For running a power analysis for an independent samples t-test, the first thing we want to do is ensure that the test family is set at t-tests. We then want to choose the statistical test. And for this example, from the drop-down menu, we are going to choose means and difference between two independent means, two groups, as this is what we have with our independent samples t-test. As mentioned previously, there are several types of power analysis we can conduct. In this example, we want to conduct an a priori power analysis, where we're going to compute the required sample size given the probability value, power, and effect size. Based on our hypothesis, it is possible to conduct a one-tailed or a two-tailed power analysis. A one-tailed will be used with a directional hypothesis, where based on previous data or literature, we have a clear expectation of which group will be higher in our t-test mean. In this example, we are going to conduct a two-tailed test, which we would use when we do not have a clear directional hypothesis. If you hover the mouse over the effect size bar, Gpower will display some conventional criteria for small, medium and large effect sizes. So for the first example, we are going to use a medium effect size of 0.5. For the power level, we are going to set this at 0.8, as this is generally accepted as the minimum power level used within social sciences. The allocation ratio is based on the number of participants in each group. In the present example, we will be aiming to have the same number of participants in each group for our independent samples t-test. Therefore, the allocation ratio is 1. Now that we have entered all the input parameters, we can click on Calculate to see the total sample size required for this analysis. This gives us a total sample size of 128. Telling us that we need 64 participants in each group to find significant differences between the group in the independent samples t-test. This is based on a medium effect size of 0.5. We could, however, calculate our own effect size based upon data that we had from a previous study, or for example a pilot study. To do this, next to effect size we click determine. Doing this opens up an extra window where we can enter information about groups from a different study, for example a pilot study, to calculate an effect size. The top option is for when we have unequal sample sizes in our groups, and the bottom option is for when we have equal sample sizes within the groups. So we're going to start with when we have unequal sample sizes from our pilot data. For these type of examples, it is important that although the two groups are unequal, they have the same standard deviation. So for this option, we input the mean for group 1, the mean for group 2, and the standard deviation, which is the same for both groups. So in this example, as the standard deviation for both of our groups is the same, although the group sizes are different, we can proceed to calculate the effect size. To do this, we just enter the mean for group 1, the mean for group 2, and the standard deviation. Then click Calculate and Transfer to Main Window, and then click Calculate in the main window to find out our estimated sample size. By calculating our own effect size from the means of previous data, we have ended up with an effect size of 0.71, which is much higher than the effect size we used in the previous example. Gpower has estimated that we would need a total sample size of 64, with 32 participants in each group, to find a significant effect with the t-test. If we switch to the Protocol of Power Analyses tab, we can see the text file that has been produced, and also there are options to save this text file and print. Next we're going to look at how to calculate the effect size when we have equal sample sizes for our groups. For this example, we are going to use the bottom option. For this, we need that our pilot study has two groups where the sample size is equal, but the standard deviations of the two groups are different. Again, we simply need to enter the mean for each group and the standard deviation for each group. If we click Calculate and Transfer to Main Window, it will calculate the effect size based on the data we have just entered and transfer this to the effect size box in the main window. Based on this information, Gpower has calculated an effect size of 0.75. This is much higher than the medium effect size we used in the first example, and slightly higher than the effect size calculated from the previous example using unequal sample sizes. If we click on Calculate in the main window, Gpower will calculate the sample size needed for this new effect size. In this example, based on the effect size we calculated from our own data, Gpower has estimated that to find significant effects in our t-test, we would need a total sample size of 58 participants, with 29 participants in each group. If we are trying to calculate an effect size from a previous study or a pilot study, where the sample sizes between the two groups are unequal, and the standard deviations are unequal, then we can't use either of the two options previously shown. In this case, it is recommended by Gpower that the researcher should delete several cases so that the sample size becomes equal. We are now going to look at how to perform a power analysis for a regression. Here, we are wanting to calculate how many people we need for a group of predictors to predict an amount of variance that is different from zero. This type of power analysis uses an F-test. So we need to select this under Test Family. And the statistical test that we are going to select is linear regression, fixed model, R-squared deviation from zero. Again, if we hover our mouse over effect size, we can see some conventional values for effect sizes. So 0.02 is a small effect size, 0.15 is a medium effect size, and 0.35 is a large effect size. Again, we're going to set power at 0.8, and we are basing this example on the fact that we have two predictor variables, or two independent variables. Once this data is entered, we can click Calculate to see how many participants we would need for a regression analysis based on a medium effect size. So for this example, Gpower has calculated that we would need a total sample size of 68 participants based on the values we inputted. It is also possible to enter our own values based upon pilot data or previously researched data into a similar example. To do this, we click on Determine. The first way we're going to look at how to calculate the effect size for a regression is from the correlation coefficient. This is where we take the correlation from a previous study which has used the same independent and dependent variables to calculate our effect size. So for this, we take the R squared from the previous study and enter it in the squared multiple correlation box. Click Calculate and transfer to main window, and again click Calculate in the main window. This will use the effect size created from the R squared of a previous study to determine the sample size. Based on this example, we would need a sample size of 74 participants. A final way we can calculate the required sample size by calculating our effect size is from predictor correlations. So we need to select this box in the Determine option. As with the first example, we are going to have two predictors, so we need to change the number of predictors to 2. Next, we need to specify the matrices. This is providing Gpower with information about the correlations between each predictor variable and the dependent variable, and the correlation between the two predictor variables. In the first tab, the correlation between predictors and the outcome, we need to specify how much each independent variable correlates with the dependent variable. In this example, predictor 1 correlates with an R of 0.4 and predictor 2 correlates with an R of 0.5. So we need to enter these into the matrix. We then need to enter the correlation between the predictors. In this example, the correlation between the two independent variables is 0.3. So again, we need to enter this into the matrix. And then click on Calculate Row to find the coefficient row. Next, click Accept Values and then Calculate to determine the effect size. This has given us an effect size of 0.47. If we click Calculate and Transfer to main window, we can then conduct a power analysis using this effect size. If we then click Calculate in the main window, the results show that based on the effect size we have calculated, we would need a total sample size of 24 participants. Next, we're going to look at how to run a power analysis for a one-way repeated measures ANOVA. The test family for a one-way repeated measures ANOVA is again F-tests. However, this time, under statistical test, we're going to choose ANOVA repeated measures within factors. We are again going to set power at 0.80, and for this example we have one group. The number of measurements is 4, so this means that the group have been measured at 4 different time points. And we're going to set the correlation amongst the repeated measures, so how much the 4 time point values correlate with each other, at 0.6. This correlation is the average correlation among the 4 time measures. The non-sphericity correction is only applicable if there are more than 2 time points, which we have in this example. We are going to assume that sphericity has been violated, so the adjustment we are going to apply is 0.8. We now need to determine the effect size. To do this, we click on Determine. We are going to use a direct method where we calculate the effect size based on the partial eta squared. This value can be produced when running an ANOVA in SPSS. So for example, we could have this value based upon pilot data or data from within previous literature. And we are going to use a medium effect size of 0.06. If we then click Calculate and Transfer to Main Window, the effect size we have calculated based on the partial eta squared will be moved to the main window. The effect size calculated is 0.25. If we click Calculate within the main window, Gpower will show us the total sample size needed for this study. Based on the values we entered, it is estimated that we would need a total sample size of 22 participants. The final power analysis we are going to conduct will be for a Factorial ANOVA. For this, we will need to calculate the sample size required for the main effects and also the interaction. The statistical test we need to choose is ANOVA, fixed effects, special with main effects and interaction. We first need to determine the effect size. Again, we are going to use a direct method using the partial eta squared. We're going to use the value for partial eta squared of 0.03. This is in between a small and a medium effect size. We're going to use this as effect size for interactions are generally smaller than for main effects. Click on Calculate and Transfer to Main Window to move this calculated effect size to the main window. Again, we're going to set power at 0.80. The numerator degrees of freedom is calculated by the number of levels of the independent variable minus 1 for the main effect. In this study, we have 2 independent variables, one with 3 levels and one with 2 levels. First, we will calculate the effect size needed for the main effect for the independent variable with 3 levels. So our numerator degrees of freedom is 3 minus 1, resulting in a value of 2. The number of groups is the number of levels in the first independent variable. So for the first main effect, this is 3. We can now click on Calculate to calculate the total sample size needed for the main effect of the first independent variable. This results in a total sample size of 315 to find a significant main effect in this study. Next, we will look at the main effect for the second independent variable. This independent variable only has 2 levels, so the numerator degrees of freedom will now be 1. And as we only have 2 levels in this independent variable, the number of groups is 2. If we again click Calculate, we can see the total sample size required for the second independent variable to find a significant main effect. The results show that for this second independent variable, we would need a total sample size of 256 to find a significant main effect. Finally, we will look at the sample size required to find a significant interaction between the two independent variables. For the interaction, the numerator degrees of freedom is equal to the number of levels of the first independent variable minus 1 multiplied by the number of levels of the second independent variable minus 1. The first independent variable has 3 levels and the second independent variable has 2 levels. This gives us the numerator degrees of freedom for the interaction of 2. The number of groups for the interaction is the product of the number of levels for each independent variable. So for this example, it is 3 for the number of levels for the first independent variable, multiplied by 2 as the number of levels for the second independent variable, giving us the number of groups as 6. We can then click Calculate to work out the number of participants needed to find a significant interaction. We can now click Calculate to work out the number of participants needed for the interaction. This has calculated a total sample size of 315 participants. Based on this power analysis, for this study we would need 315 participants, as this would enable us to detect significant main effects and interactions. There is more information on how to run power analyses using Gpower on the UCLA Stats website. More information can also be found on the Gpower help pages. This concludes the screencast for power analysis. We have looked at how to conduct a power analysis to determine sample size for independent samples t-tests, multiple regression, a one-way repeated measures ANOVA, and a factorial ANOVA.